So finally, the quadratic formula, section 4.4. Okay, this is probably the most important section possibly in the whole course. Okay, this formula is very important, very, very useful. And what it will allow you to do is solve any quadratic equation. Okay, basically. Also, using one part of it called the discriminant, which you can see here, will let you know what types of roots you're going to get. Okay, so without even solving for it, you can already know very quickly whether there'll be two roots, two identical roots, or one root, and then if there's no roots. Okay, you can do all of this without graphing, just using this formula. Now, to derive it, maybe I'll just spend a second to take a look. This is a great idea. Deriving it is just going to use completing the square. You can think about if you had the standard form, if you thought about it, okay, maybe if you were super clever beforehand, you're like, well, if I could just solve this generally, that would give me a formula with respect to these parameters. So you have to be in standard form to use this. So if you're in vertex form, you're going to want to move to standard form to use the quadratic formula. But basically, the proof of this is simply to just solve for x here. And you're going to solve for it using the method that I showed you in 4.3. So that's where that comes into play. Right? So you can see this is all in general. Okay? And as you go down here, you complete the square and simply solve for x by square rooting both sides. It gets quite convoluted because you're dealing with three parameters that you're not reducing. Okay, it might reduce in real life, or sorry, when you use real examples, but when you do it in general, you can't. And at the end of the day, this is what you're left with: x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This should be committed to memory without a shadow of a doubt. Committed to memory. Okay, definitely have that one memorized, and you will have it memorized. You're going to use it so often that it will be easy to memorize. Okay, there it is, your little square box. You can square this off in your notes. Not as ugly as I just squared it off. Okay, so here we go. Very simply, the first thing we're going to do before we actually solve quadratic equations, I'm going to give you stuff, any quadratic equation, you put it in standard form, you use the formula, but this guy right here is called the discriminant. And it will tell you if there will be real solutions, if there won't be any solutions, what type of solutions you'll get. Remember, actually, something you should remember is you can't square root a negative value. Can't square root a negative. That means if b squared minus 4ac so happens to be negative, this equation is not possible. It's not. There is none. Okay? In that case, it would be above or below the x-axis and pointing away so that it does not intercept with the x-axis. Okay, that's the graphical interpretation of that. So when you look at the discriminant, which is what we're going to start with, if it's greater than 0, then you're actually going to have two distinct real roots. If it's equal to 0, you're going to have one real root. Okay, that would be the example of x squared when it touch and goes like that. Okay, this one would be something where it's a bit below. Okay, it's greater than 0. And then this last one is if it's negative, that means you're in a situation like this. Okay. So just by looking at b squared minus 4ac, you can tell if something has roots or not. So for instance, if you had this guy, it says it's an equation, but it's not. It needs like an equal 0 here. Just by looking at b squared, which is 6. So 6 squared is 36 minus 4ac, which is minus 4 times 2 times 10. Gives you negative 44. And that's a negative value, so there's no roots to this. So when you graph this on Desmos or by hand or whatever, you should see that this does not intercept. This does not pass the x-axis. So let's do some examples very quickly here. Okay, for part A, I'm going to switch colors. Let's do this in red again. X squared minus 5x plus 4. We could solve this, but let's just determine the nature of the roots. Sometimes you might not be interested in solving it. You might just be interested in the nature of the roots. In which case you're going to look at this. B squared minus 4ac. B squared, well that would be negative 5 squared. Use brackets here because it's the square is it's going to be negative 5 times negative 5 in this case. Minus 4 times 1, that's A, times 4, that's C, right? A equals 1, B equals negative 5, C equals 4. I'm reading off the coefficients, okay, in front of these guys. This comes out to be 25 minus 16. At this point, I actually don't care what this comes out to be. It's very easy to do in my head as 9, but if it's really large values, you could just say positive number. It really makes no difference because this is positive, this is greater than 0. Therefore, there are 2 real solutions. 2 real distinct solutions. For B, so now you get the idea of how I'm going to do this. B squared minus 4ac would be 4 squared minus 4 times 3 times 4 over 3, which is 16. 3 times 4 over 3 is just 4, so it's going to be minus 16 equals 0, which means there is one solution, one distinct real solution. When I say real, I'm talking about the real numbers are, okay? And the last one we're going to talk about here is negative 8 squared minus 4 times 2 times, let's just rearrange this because you're going to want to be in standard form, which is ax squared plus bx plus c equals 0, so you're going to move c over. So it's actually positive 9. I wonder what this is going to be. Negative 8 squared is 64. Now, minus 4 times 2 is 8. 8 times 9 is 72. You don't even have to calculate this, right? This is negative. Okay, and I'm stressing that because, I mean, these are easy to do in your head, but eventually you're going to get big ones, really, really large numbers that don't waste your time with. This is negative, therefore, no real solutions. Okay? So, when you're working with a quadratic equation, you want to solve it, you're not going to look at this first and then go to the quadratic formula. You're going to flat out try to plug it in, and when you notice that the discriminant is negative, you're just going to stop doing it. Okay? So, let's move on to some examples. Determine the roots for each quadratic equation using the quadratic formula. Very good question. Let's do it. So for part A, 3x squared plus 5x minus 2. Okay, I swear we did the same one for the 4.3 section when we completed the square. If you wanted to use the quadratic formula from this, remember the quadratic formula is x, actually I'll write it up here, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative b is negative 5 plus or minus the square root of b squared is minus 25 minus 4 ac. Sorry, I should probably show my work here. There we go. All over 2a. So what we're left with is negative 5 plus or minus, and what we're left with is 4 times 3 times negative 2. So we actually have 25 minus negative 24. Because we have two negatives here. Eventually it's going to come out to be a positive, so don't be deceived or don't be tricked by that. Okay, watch your steps. And this is going to be 25 plus 24, which comes out to be 49 all over 6. We didn't do this question. This is a different question here because 49 is 7, so we have negative 5 plus or minus 7 over 6, which is negative 5 plus 7 over 6, or negative 5 minus 7 over 6. So this will come out to be 2 over 6, which is 1 over 3. Okay, that's one solution. Or x equals negative 12 over 6, which comes out to negative 2. You know? So you need to say, like, good luck guessing these factors, okay, using guess and check. Quadratic formula is essential. If you use a computer, if you get a computer to solve these in standard form, this is probably how it would do it. For B, yeah, I'm going to get some more room here. I'm going to erase this though, so hopefully that makes sense. We're all good. I'm going to do the same thing, except this time with those different parameters. So for B, we have x, actually, sorry, we have t, because we're dealing with that. Now b squared is going to be, or b negative b, it's going to be negative 1, like that, plus or minus b squared, which is negative 1 squared, minus 4 times a, which is 1/2, times c, which is negative 5 over 2, all over 2 times 1/2. It's a bit annoying. I'm going to try to watch my writing here. So we actually have 1 plus or minus the square root of 1 minus, this is going to come out to be a positive number. We get 4 times 1/2 is 2. Okay, so 2 times negative 5 over 2 is just going to be negative 5. So it's going to be minus negative 5 all over 1. Very simplifying. They're simplifying very well. They don't always do this. Okay. So this will be 6. 1 minus negative 5 is 6. So here t is equal to 1 plus root 6 and 1 minus root 6. Just like that. Now, of course, you can check your work by plugging it back in. Might be a bit tedious, but it certainly could. It will give you. It will satisfy the equation. So, I suppose the last little example, that's it. I mean, there's nothing else I can really show you here. I just want to highlight that when in doubt, use the quadratic formula. So if you're looking at something you want to do by guess and check, and even though if you say to yourself, I should be able to do this by guess and check, but you just are struggling with it, just plug it into the quadratic formula, and that will give it to you. Now, sometimes though, I mean, let's do one more question. Here I'm leaving the method open, and I'm going to do that often on the exams and quizzes. You know, I'm not going to really care what method you use. Sometimes if I want to test for the quadratic formula, I'm going to test for it. I'm going to say use the quadratic formula, and the same thing with the other methods. But I'll give you one that's open, and you're going to basically be led towards one method. And this one, if you were to face this, which method would you choose? Guess and check, decomposition, completing the square, or quadratic formula? And I think your only option here would be completing the square or quadratic formula. Out of the two, I'd feel more comfortable using the quadratic formula. So one last example. X equals negative b, right? Negative, like that, plus or minus the square root of b squared minus 4ac all over 2 times 0.57, which is a. So despite how hideous these numbers are, it really makes no difference, because when you do it, formula will take care of itself. When you square that number, you get, that's not a g, that's a 6. Sorry, this program is being difficult to write in right now. 6, there we go. And then it'll be subtracted by, this again will be a positive number at the end of the day. And I'm just plugging this into a calculator. Okay. All over 2 times 0.57, 1.14. So we get 3.7 plus or minus square root of this, 13.69 plus 5.7 is 19.39 all over 1.14. When you make this equal, you get 3.7. And given the nature of this question and how ugly all these roots are, I mean, we can keep this. Let's see how ugly this comes out to be. Square root this. Yeah, it's a long decimal. And I'm looking at this root right here. That root there. I'm just going to leave it like this, actually. Okay, 19.39. All over 1.14. That could be one solution. Okay, that could certainly be one solution. Or it could be 3.7 minus. Now, if the question said, you know, report your answer to 2 decimal places, you can get a definite answer here. You're just gonna have to square root this 19.39, and you'll have to approximate it. Okay, but this is actually an exact solution given the question at the top, and I typically prefer exact solutions. So that's it. That's the quadratic formula. So there's nothing philosophically difficult or deep about it in terms of decision making. It's quite easy. One thing I have to stress before I let you go here is it has to be in standard form. Okay, get the quadratic equation in standard form, and then plug them in, and you have solved your quadratic equations. So do the practice problems, then do the assignment, and then you're ready for the exam. Ask me if you have any difficulties.